Hello, students. Welcome to a new year and to my online students, my viewers. You all are welcome to New Year 2026. Today in chemistry, we are going to look at a very interesting topic, particulate nature of matter. We are going to discuss basically the atomic structure, what makes up an atom, the atomic composition of an atom. All right? Then, particulate nature of matter. In the last video, we talked about matter to be anything that has mass and occupy a space. Then I told you that matter has three physical states of existence, which are solid, liquid, and gas. Matter can exist in form of solid, matter can exist in form of liquid, and matter can exist in form of gas. And I told you guys that matter has the ability to change from one state to another. It can change from one physical state to another, and that is achieved as a result of changes in temperature. All right? Matter changes from one state to another in response to great change in temperature. All right. Today we are going to discuss the atomic structure, how atoms looks like. First of all, what is atom? Atom is a part of an element, the smallest particle of an element that can take part in chemical reaction is atom. All right? Being part of an element, that shows that atoms come from an element. Do you understand? So first of all, I think we need to start from the definition of element. We need to start by defining what element is. What is element? Element is the smallest particle of a substance that cannot be split into any simpler form by a chemical method. It is the smallest particle of a substance that cannot be simplified into the simpler unit by a chemical method. Element is the smallest particle of a substance that cannot be split into their simpler form or unit by any chemical method. All right? And that is the definition of element on the whiteboard. It is the smallest particle of a substance that cannot be split into their simpler form or unit by any chemical method. Okay? That is what element is. Now, atom. Atom here is the smallest particle of an element that can take part in chemical reaction. Atom is the smallest particle of an element that can take part in chemical reaction. The word atom is derived from the Greek word known as atomos. Do you understand? Atom is derived from the Greek word known as atomos, which means smallest and indivisible. Atomos means smallest and indivisible. So in this case now, you can state that atom is the smallest and indivisible particle of an element. Atom is the smallest and indivisible. Atom is the smallest and indivisible particle of an element that can take part in chemical reaction. All right? That is the definition of an atom in chemistry. All right? Now, we are going to look at another definition here. This is molecule. Molecule, which is the smallest particle of a substance that can exist alone and retain the chemical properties of that substance. Do you understand? All right. Molecule is the smallest particle of a substance that can exist alone and retain the chemical properties of that substance. But take note, molecule is formed by group of atoms of either the same element or different elements. All right? Group of atoms of either the same element or different element forms molecule. Do you understand? For example, an atom of hydrogen combined with atom of oxygen. Do you understand? Two atoms of hydrogen combined with one atom of oxygen will give us this molecule known as water molecule. Do you understand? This is a typical example of a molecule as a group of atoms of either the same or different elements. You understand? Now, you can have this as a molecule. This is oxygen molecule. All right? Then here is oxygen atom. All right? Take note. Atoms can be represented by the symbol of the element. It's used to represent the atom. Do you understand? Now, let's look at the atomic structure. The structures, the compositions that makes up an atom. Okay? Okay. This is the atomic structure. The atomic structure. Okay? We have two main particles that makes up an atom. The first here is the nucleus. Nucleus. Then here, here, and here is known as the shell. These are the two atomic particles. We call these two atomic particles. The atomic particles are shell and the nucleus. All right? The shell and the nucleus makes up the atomic particles. Now, inside these atomic particles, we have some other particles that makes up an atom. Do you understand? Then, in the shell, we have only subparticles. We call these subatomic particles. The subatomic particles. We have here the electron. Then we have two subatomic particles here, which are the proton and the neutron. The proton and neutron are the subatomic particles we have in the nucleus. Now, there is a part of the shell where these electrons are most likely to be found, and it has its own name in chemistry. That part of the shell where electrons are most likely to be found is known as orbital. We are going to discuss more on this when we are going to look at the topic electronic configuration. And the topic will make you understand how these electrons are filled inside their orbitals, which is located in the shell. Do you understand? Now, looking at these subatomic particles, they have their charges. All right? They have their respective charge. The electron here is negatively charged. The proton here is positively charged. Then electron here is neutral. There is no charge on the neutron. All right? It is electrically neutral. Now, electron was discovered by a man known as J.J. Thomson. J.J. Thomson discovered electron. Okay? Then the proton and the nucleus of an atom was discovered by Ernest Rutherford. Ernest Rutherford discovered the nucleus and the proton of an atom. Okay? Then the neutron was discovered by James Chadwick. James Chadwick discovered the neutron of an atom. Then the charge of electron, J.J. Thomson discovered electron. Then the charge of an electron here is discovered by Robert A. Millikan. This is the man that discovered the charge of electron. Now, having said this, let's go further again. Here is electron. The charge is negatively charged. All right? In terms of mass, that is the size of these subatomic particles. The mass of proton is equal to the mass of neutron. Okay? That is to say, if the size of proton is 1, that of neutron is 1. Do you understand? Remember, the two are located in the nucleus of an atom. All right? Now, in terms of the mass or the size of the electron, electron is the smallest among these three subatomic particles. All right? When compared to the proton and neutron, the mass size of electron is 1 over 1840 of the size or mass of proton, or you can say neutron, because proton and neutron have the same mass or the same size. Do you understand? Now, in every atom, numbers of proton is equal to the numbers of electron. The proton number is equal to that of the electron. Because the proton is positive, the electron here is negative. This shows that positivity entity of an atom is constantly equal to the negativity entity of an atom. And because of that, we already know that neutron is electrically neutral. It is neither positive nor negative. And the positivity is equal to negativity entities, right? You can simply say that an atom is electrically neutral. Atom is electrically neutral. Why? Because the numbers of proton is equal to the numbers of electron. Do you understand? Now, that's what we call atomic number. All right? Atomic number of an element is the number of proton, which is equal to the number of electron. Still obeying these concepts. Atomic number of an element is the number of proton which is equal to the numbers of electron of that same element. Because proton number is constantly equal to the numbers of electron, and for that reason, atom is said to be electrically neutral. Do you understand? Now, having defined the atomic number, which is equal to the proton number and also equal to the electron number, because proton number is equal to the electron number. Let's look at the atomic mass number. Okay? Before we move into that atomic mass number now, look at what we meant by this explanation. In the nucleus, we have proton. If we have one proton here, we are going to have one electron here on the shell. All right? And if it's only one proton and one electron, we are not going to have all these shells. Here is the K shell, here is the NO shell, here is the MO shell. Then if it continues, we have NOP shells. You understand? Now, then if we have two protons, we are going to have two electrons because numbers of proton is equal to numbers of electrons. So take note again. As we have proton in the nucleus, as we said in the beginning, we have electrons here on the shell. Now, the part of the electron where these electrons are most likely to be found is known as orbital. Do you understand? The part of the shell where electrons are most likely to be found is known as orbital. All right? Then here we have our neutron. Neutron. Do you understand? Okay. Now, let's look at the atomic mass number. I'm going to wipe everything. Let's look at the atomic mass number, okay? The atomic mass number is determined by the nucleus. The atomic mass number is determined by the nucleus. Why? Because what determines the atomic mass number is the sum of the proton number and the neutron number, which we have housed inside the nucleus of an atom. And that is why the nucleus is what determines the atomic mass number of an atom. All right? Okay? What determines the atomic mass number of every atom of an element is the sum of the proton number and the neutron number of that particular atom of an element. Do you understand? That is to say, if you add the proton number with the numbers of proton, that will give you the atomic mass number. Do you understand? All right. We are going to discuss about how to calculate and get the atomic mass number of an element in the next video. Then in that video, I will explain to you how we add the proton and the neutron number to get the atomic mass number. But take note, in some atoms, proton number is equal to the numbers of neutrons. Do you understand? While in some atom, the neutron number is more than the numbers of proton, but can never be less. Do you understand? There is no atom that have lesser numbers of neutrons than that of the proton. We don't have that in chemistry. All right? But we can have neutron number be more than that of the proton number. Do you understand? All right. Okay, now let's look at isotopy. Having discussed the atomic mass number here, now let's look at isotopy. Remember, I told you in the next video, we're going to discuss how to calculate the proton with that of the neutron number, adding them together to get the atomic mass number of the first 20 elements. We're going to do that in our next video. Now let's look at isotopy. Okay, isotopy is the phenomenon whereby atoms of the same element have the same atomic number but different mass number as a result of difference in the neutron number. Okay, what makes isotopy to be possible is as a result of difference in the neutron number. Do you understand? This concept is not applicable in every atom. All right? We have some atoms that exhibit this isotopy. All right? Atoms of the same element having the same atomic number, which can never be changed. All right? Their atomic number is constantly there, the same. You understand? But with different mass number. And I told you, proton number is the same as the atomic number, which is equal to the numbers of the electron, if you remember. All right? Now, the mass number, which is not the same in the concept of this isotopy, is as a result of the difference in the neutron number. Remember, I told you, when you add the proton number and the neutron number, it will give you the atomic mass number, which we define here as the mass number of an atom. Do you understand? So in a situation where the mass number of two atoms of the same element are not the same, what could be the cause? If the atomic number cannot be changed, likewise, the proton number is the same thing with the atomic number, so it cannot be changed also. Do you understand? So what makes the mass number to differ? That is the mass number of two atoms or three atoms of a particular element. What makes the mass number to differ is as a result of difference in the numbers of neutrons, because proton number and atomic number is fixed. It cannot be changed. All right? Then you add the proton number with the neutron number. It will now give you the mass number, which is not the same here, of two atoms of a particular element. So it is as a result of difference in the neutron number. Do you understand? Now, these atoms of the same element that exhibit this isotopy is known as isotopes. All right? Now let's look at isotopes here. All right? Isotopes is the atom of the same element which has the same atomic number but different mass number. Do you understand? Or you can say that isotope is the atoms of the same element which has the same proton number. Do you understand? Which has the same what? Proton number. Why? Because proton number is the same as the atomic number. You understand? You can also say that which has the same electron number or proton number or atomic number but different mass number as a result of difference in the numbers of what? Neutron. So what makes isotopy to be possible is as a result of difference in the numbers of neutrons. Do you understand? Now let's look at those atoms that exhibit isotopy. We are going to look at the isotopes of some elements that exhibit isotopy. Do you understand? All right. Atoms that exhibit isotopy. Number one is hydrogen. We have how many isotopes of hydrogen here? We have 3 isotopes of hydrogen. All right? We have hydrogen like this. 1 and 1. We have hydrogen here. 1 and 2. We have hydrogen here. 1 and 3. Do you understand? Okay, now, these numbers here represent the atomic number, which is equal to the proton number or the electron number. Do you understand? These numbers here are the atomic number. 1, 1, 1 are the atomic numbers. Now, the numbers we have here, you can see that 1, 2, and 3. Here are the mass number. Do you understand? 1, 2, and 3 are the mass number. Now, how do we get this one now? Proton number plus neutron number will give us the mass number. Do you understand? Proton number plus neutron number will give us the mass number. Let's write it here. Proton plus neutron number will give us the mass number. All right? In the case of this hydrogen here, the proton number here is 1. There is no neutron. You will understand this in the next video I told you about. Proton number is 1. Neutron number is 0 because there is no neutron in this particular hydrogen. That is why the mass number here is 1. Is as 1 plus 0 is 1. Do you understand? Now, in this case, we have 1 proton, we have 1 neutron. If you add the proton with the neutron, it will give you 2. And that is why the mass number here is 2. Then in this case here, we have 1 proton, we have 2 neutrons. If you add 1 proton to 2 neutrons, it will give you what? 3. And that is why the mass number of this hydrogen here is 3. Do you understand? Now, this hydrogen that have no neutron, which have mass number 1, is known as protium. Protium. Then the hydrogen atom that have 1 proton and 1 neutron, which has atomic mass number 2, is known as deuterium. Are you following? All right. Now, the hydrogen atom that have 1 proton and 2 neutrons with the mass number 3 is known as tritium. This is known as tritium. But among these 3 isotopes of hydrogen, protium is the one that is most in abundance. All right? Because of its size, it is more in abundance. Take note, in every isotope of an atom, the one with the least possible number of neutrons or the least possible numbers of the mass number is the one that is more in abundance. So it is not only applicable to hydrogen. Do you understand? I will still show you other isotopes of different elements and the one that is more in abundance. All right? Now, the next isotope we're going to talk about here is oxygen. Oxygen exhibits isotopes. We have 2 isotopes of oxygen. We have oxygen 16 and oxygen 17. All right? Then atomic number of oxygen is 8. Here is 8. Do you understand? Remember I told you, despite isotopy, neutron number can never be less than the proton number, but it can be more. In this case, where we have isotopy to be possible. So in this case now, this oxygen here, proton number here is 8. Are you following? Neutron number here is 8. And that is why the mass number here is 16. 8 plus 8 will give us 16, the mass number. Now here, proton number here is 8, neutron number here is 9. That is why the mass number here is 17. The one that is more in abundance is oxygen 16. This is the isotope of oxygen that is more in abundance. Do you understand? That the next element that is with isotopy is carbon. Carbon. We have two isotopes of carbon also. Carbon Sb2 isotope. All right? We have carbon 14. We have carbon 12. All right? Okay, let me write it like this. We have carbon 14 here. We have carbon 12. The atomic number is 6 and 6. Are you following? In the case of this carbon, atomic number of carbon is 6 because the proton number here is 6. Do you understand? Then, the neutron number of carbon here is 6 also. That is why if you add 6 to 6, it will give you 12, which is the mass number of the carbon. Do you understand? All right. For this case, let us solve this as simple mathematics because I can't be making all of them in this simple way for you to always understand the way to get it right. Now look here. We have proton adding to neutron, then the mass number. Okay? Now, the proton number here is 6. Are you following? Then the neutron number here is unknown. You understand? Then the mass number here is 14. So now what do? You collect the like term. All right? And we stay alone equal to 14. All right? 14. This will cross over to equality sign and change to -6. All right? Therefore, 14 minus 6 will give us what? 8, bar. That will give us 8. So in this case now, the proton number here is 6, the neutron number here is 8, the mass number here is 14, and that is carbon 14. Do you understand? Okay. The last we are going to look here is chlorine. That is chlorine here. Sb2 isotope. We have chlorine 35 and chlorine 37. Atomic number is 17. Atomic number here is 17. Then remember in this case, the one that is more in abundance is carbon 12. Carbon 12 is the one that is more in abundance. That is the most abundant carbon is carbon 12. We have chlorine 35 and chlorine 37. Okay? Likewise, as we do before, the proton number here is 17 plus unknown equal to 35. Okay? Then here we have collecting the like term as we do before. Here we have it here. Collecting the like terms as we did before. N alone is equal to 35. This will cross and change to -17. All right? Then the neutron number here is equal to 18. All right? 18 plus 17 will give us 35, which is the mass number. That is to say the neutron number here is 18. All right? Likewise, in this case, the neutron number here should be 20. All right? 20 plus 17 will give us 37. All right? You can also use the same format I did here to solve for how to get this 20. I believe you can do it yourself. It's very simple. All right? Now, we have an instrument that is used in chemistry to determine the mass number. We call it relative atomic mass number of atoms of an element. All right? The instrument used to determine the relative atomic mass number of an element is known as mass spectrometer. The instrument is known as mass spectrometer. It is used to determine relative atomic mass. All right? Then it is used to determine relative abundance of an element, mass spectrometer. And that is why the relative atomic mass number here is defined because carbon 12 is the one that is used to determine the relative atomic mass in chemistry. Why? Because the relative atomic mass number in some of our textbooks in chemistry states that is the mass weighed by one atom of an element on a device in which carbon 12 weighs 12 grams. That means carbon 12 is the element that determines the relative atomic mass number. All right? That instrument that weighs carbon 12 to have 12 grams in weight is used to determine the relative atomic mass number of different other elements we have in chemistry. Please, this is where we are going to stop for today. Thank you and God bless you. Don't forget to subscribe to our YouTube channel. You can like, drop your comment in the comment section. Thank you and God bless you.